This is the circuit board of a Hitachi refrigerator that came in for repair. Someone had previously worked on it and replaced some components. Despite changing those parts, the issue persists. They replaced the IPM, the optocoupler, capacitors, and the rectifier. So quite a bit of work has already been done. Now, we are going to check this circuit board. We'll power it on and provide a complete detailed explanation. Upon powering the PCB, we'll check the voltages at different points. The light turns on and is blinking, as you can see. It's blinking twice. First, we'll check capacitor C22. There should be 12 volts at C22, and we'll take the negative ground from here. So the ground point is this one, and the 12-volt point is over here. We're getting 12 volts exactly, which is fine. Next, we'll check the output of the IC where capacitor C30 is located. There should be 5 volts at this point. Upon checking both points, we are indeed getting 5 volts, so there's no issue there. Now here a diode symbol is made, but this isn't a diode, rather it's just a direct point of the capacitor, and there should be 12 volts here. Let's check it again, and I will take the ground from this point at the back. Upon checking, we're getting exactly 12 volts, so everything is good at this position. And one more thing to remember is that the ground on this side and the ground on the other side are different. The IPM microcontroller and the other microcontroller have separate groundings, and their voltages are completely different from each other. They don't match at all. So when we check for 5 volts here, we'll take the ground from this side and check. Indeed, there are 5 volts present. Additionally, there is ground available on the other side as well. So we'll check that too. Yes, ground is present there as well. There is one ground point here, so we'll reverse the polarity and check again. Yes, ground is present here as well. Now there should be 15 volts at this point, so let's check for 15 volts. We already have the ground here, and upon checking, we're getting around 15 volts. Specifically, it's showing 14.05 volts, which is acceptable and can work fine. Now, let's check this capacitor attached to the 7805 voltage regulator. We'll check the voltages here, and there are 5 volts present, which is exactly correct. So all the voltages are coming in exactly as they should be. Now let's check the IPM. When we check it, it shows 319.2 volts, and then we check from negative to positive. Upon checking positive, it shows 13.46 volts. Further checking shows that everything is fine. Lastly, we'll check the third point, and there's no problem there either, which means that all the voltages are correct. There is no issue with the PCB. Now, we'll take this PCB to the site and test whether it operates properly or not. We've now arrived at the location where the issue with the refrigerator was reported. This is a Hitachi refrigerator with both fridge and freezer compartments, a double-door unit. Upon opening it, I can see that it has dual fans and cooling inverter is written on it. I'll also provide the serial number. Here you can see all the details, and here's the circuit diagram and wiring diagram. The compressor installed is the original Hitachi compressor, and it uses R600A refrigerant. Now taking a flat screwdriver, I'll push the connector, and it's come out. Here you can see the overload protector, which works at approximately 120 volts. If the compressor heats up to 120 degrees, the overload protector will trip the compressor to stop it from running. That's how it functions. Next, we're going to test the compressor and check its windings to ensure there's no short circuit. Now, checking the values here, everything looks good. After this, we'll install the PCB. We need to confirm that the compressor isn't short-circuited. If the PCB is working fine, but there's an issue with the compressor, it could damage the PCB again. That's why we first check the compressor. Upon testing, the compressor's values are all correct. Now we're checking for any leakage in the compressor, and it's fine too, no issue here. Next, we'll proceed to install the PCB. Now, all the connectors have been properly seated. First, I installed the PCB, and now the supply connector, followed by the defrost connector, and the reactor connector, are seated in their respective places. I've installed them properly. Next, these are the DC fan motors, which I mentioned earlier. There are 2 double fan motors, which I have also installed. Then, I installed the display connector and some other sensor connectors, all placed in their proper positions. Here's the reactor connector, which we've now installed as well. Now, we're going to install the analyzer. Next, I've installed the UVW connector. After installing UVW, if the analyzer turns on, it means we can proceed with the next steps. If it doesn't turn on, we'll know there's still a fault, and we can check what's wrong with the unit at this time. Now, we've turned on the power, but as you can see, the system has started showing an error. It's blinking 7 times. A 7-blink error indicates an overcurrent issue. We already knew that the unit had previously suffered damage to the capacitor, IPM, rectifier, and DC fan optocoupler, which had all burned out and were replaced before bringing the PCB to us. But even now, it's giving 7 blinks, which means the PCB is still faulty and unusable. Look at the compressor connector here. Even if we connect the compressor, it won't work. Now let me explain why we were getting 2 blinks. Whenever there are 2 blinks, it means there's an issue with the refrigerator's room sensor. That's why this problem occurred, because we didn't install any kind of sensor here. As a result, it's prioritizing the room sensor error and showing that. Additionally, let me confirm that whenever you get a 7-blink error code on the LED, it indicates an overcurrent issue. There's a chance that your PCB is fine and will work, meaning the problem hasn't reached the microcontroller. In that case, it will start functioning properly again. However, in our situation, the compressor is perfectly fine, but the microcontroller is completely corrupted. As a result, this PCB is dead. Even though it's working somewhat, it's practically useless and of no benefit to us. So what we will do is replace the PCB, and the unit will be fully functional. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.